So we're going to first start talking about limits for the first time. What is a limit? And as you can see the definition, and as the limit is a function, as x approaches a set value, what does the function approach? That's what we mean by this. So here we take a look at a graph. I'm going to have to go back and forth for size, but anyways. So the limit as x approaches 0. So as x gets closer to 0, so as we close in around x equals 0, what's the function value? Exactly, 0. How about as x approaches negative 2 of f of x? So again, here at negative 2, as we close in, as we get closer and closer to negative 2, what function value do we end up getting? Close to negative 5. Now, the limit does not mean at. It means as we approach. So let's take a look at 3. So as we close in on x equal 3. So again, so if we're looking at the graph, here's the graph. So we're closing in. So in this small region of the domain, what is the function value approaching? 1. Exactly. Now, how about this one? As x approaches negative 1, what's the limit of f of x? So as we close in, as we get closer and closer to negative 1, so as we zoom in there, or we close in kind of thing from there and there, what do we end up getting closer and closer to? We actually get closer to negative 3. It closes in on negative 3, approaches negative 3. Notice, the open circle means it doesn't exist at 1. So if we want f at the function value at x equal negative 1, that is f of negative 1. We don't care what happens around negative 1 there, just there and there only. The limit is what happens around it. Who cares what happens at this place? So this is the difference between a house and a neighborhood, or the house and a block. That's how small it is. So okay, how about as x approaches 2? So here's x equal 2. So as x approaches negative 2, what function value do you get? What does the graph approach one particular function value? No, it doesn't. It looks like, wait, is it 0 or is it 2? Which one is it? Well, you know what functions, we don't like that. So this limit does not exist. And we could go ahead and write it D and E. Okay? All right. How about we've seen sort of this a little bit. Let's take a look at what this notation looks like. This here. This, as x approaches negative 1, it looks like negative 1, like a valence charge of f of x. Well, this is the left hand or left side limit. In other words, we're approaching negative 1 from the left or from the negative side. That's what this little quote valence thing, and only the left side. So if we go back up to here, so here's the x equal negative 1. What is the function approaching? Exactly, negative 3. So what happens with the plus? Well, the plus is the right-handed or right hand or right-sided limit. In other words, we're approaching it from the positive side of that number. So here's negative 1 again. So we're going to approach it from the right side of negative 1. Trace that function as it goes closer to negative 1. We're approaching. Notice one thing about these two one-sided limits, the left and right-hand limits, and D. Okay, how about x approaches negative 2? Or sorry, not negative 2. 2 from the left. So 2 from the left. So here is, and again, we'll clear that out so we can see it better. 2 from the left. So here's 2 from the left side of 2. There's the function. We're approaching what number? What function value do we get closer and closer to? I. What happens as we approach 2 from the right side? So again, here's x equal 2. So from the right side of 2, that's this side over here, as we get closer and closer to 2, what function value does it approach? The function approach. Not get to, approach. Gets closer and closer to? Exactly, 2. Notice the difference between the left and right-sided limits, h and I, and e. Actually, that leads us to that theorem that you see down below, is that a limit exists and is a value if and only if the two one-sided limits exist. If the two one-sided limits exist, the limit, or vice versa. Now, you don't have to do this all the time, only when something strange happens, like the open circle, or this where it's going to two different places, like for A, B, and C. You don't have to worry about it. Nothing strange happens. We could just close in there. We could just close in there. Okay? How about this one? It's a rational function with a couple different things here. So let's walk ourselves through it. So x approaches 1 from the left. So here's x equal 1 from the left side. What number is it approaching? The function value will give you the ordered pair. X approaches 1 from the right. So as the function go from the x of 1 from the right side, it's getting closer and closer to? Are those two equal? And that's the limit. Okay, notice it's not moving left, it's not moving, it's from the left. So this is the negative side of it. This is the positive side of that number. Sometimes that makes a difference. Think about parabolas, absolute values, and other things like that. Different things. Okay, how about D? As x approaches negative 2 from the left. So here's negative 2, the left side. Up. So that's as high a value as you could. It's infinity. So what about when we approach negative 2 from the right? So here's negative 2, right side of negative 2. I'm just going to trace the graph. That's going down to negative infinity. By the way, is infinity a number? Exactly. It is not. So F. How about x equal to 2? Show us 2 from the left side. So here's 2, left side of 2 is here, so we're going to trace the graph. It's heading towards negative infinity. Here's 2 from the right side. That's the limit as x approaches 2 from the right. The function value keeps getting closer, keeps getting bigger, so approaches infinity. Now, since infinity is not a real number, this limit does not exist, and neither does this one. Now, we've seen this before in here, those, when we talked about vertical asymptotes. Okay? Actually, that's the definition of a vertical asymptote. Now, even if they would both go to, excuse me, both positive or both negative infinity, not a real number, the limit as x approaches that number doesn't exist, because this has to be a real number where 1/3 is real. And lastly, before you leave, how about as x approaches infinity, positive infinity? So again, where's positive infinity for x? All the way that way. And it looks like the function value is getting closer to? That's right. Negative infinity. So negative infinity is over there. Function value looks like it's getting closer and closer to. And we saw those before. Yep, horizontal asymptotes. So vertical asymptotes are here. Those are horizontal asymptotes. Some things you'll see later, okay? get to work on the practice there, and we'll go from there.